So this thingy today is about the absolute maximum and minimum. Okay, this thing we've been doing local max and min. Let me zoom out of this thing. Oh, not that direction. It really looks like this, right? So saying there do we even have any? Is that a local? I think this is the local min, and it does not seem to have any local max now, does it? Right? Because this thing shoots up to infinity and goes down to infinity, some kind of futuristic chair, right? And yeah, oh, that looks very comfortable now, doesn't it? Okay, right. However, we're going to restrict the boundary. So we're going to cut it off the other direction, like this. So our domain is only from x ranging from -1 to +1, y ranging from -1 to +1. Okay, so we are going to take that futuristic chair and cut it. So it gives you this surface. Now we have to find the absolute max and absolute min. Okay, from the graph, looks like this is absolute min right here at 0, 0, right? So if I plug in 0, 0, 4 will be our absolute minimum. Okay, absolute maximum though looks like these two will be absolute max, right? It certainly looks higher from this angle than this point. Good. So this, we have to calculate this without looking at the graph, which is not an easy thing to do. Okay, so let's get started. So suppose we have this function, two variable function, f of xy is equal to x squared plus y squared plus x squared y plus 4. Okay, and we want the absolute maximum and absolute minimum. Okay, I already put the sketch of that function in here. Okay, now when we are doing this, we have to sketch the region. And our region, of course, is a square, isn't it? And sometimes we have circular region and so on. So this one, for a beginner, is easy. So I'm going to put the coordinate axis right through in the middle. So this is what we are looking at. 1, -1, here's -1, and here's 1. Okay, which means we have to think about, let's review last year. Last year, say we have a function like that. And this is A and this is B. We did the first derivative test, and that'll give us these two critical points, right? And there's a little bit difference with the local max versus absolute max. Instead of second derivative test or increasing, decreasing thingy, we don't care whether this is local max or local min. Let's say this point happens to be C and this point happens to be D. We evaluate these functions at A, B, C, and D, and see whichever is the highest of all, because this endpoint also comes into the picture. Oops, when we are dealing with absolute max and min. You know what I'm saying? So between these two, whichever is greater is the absolute maximum, and between these two, whichever is smaller is the absolute minimum, wasn't it? So same idea, this interior versus boundary. Boundary comes into the picture, but you only need to evaluate this function at the boundary, so it was nice. Now we have a little more complicated issue. Interior versus our boundary is not a point, right? So considering boundary itself is uniquely challenging. You know what I'm saying? But it's still analogous to this interior versus a boundary idea. You get it? Okay, with that, I'm gonna get rid of this and we'll start our thing. So first thing is we still consider interior first, okay? So interior. In interior, we just find this f of x and f of y. F of x is equal to 2x plus 2xy, correct? And we calculate f of this, kind of like first derivative thingy. And f of y is 2y plus x squared. Good. Now we set them equal to 0. So set this equal to 0 as well as set this thing equal to 0. Okay. Now, how should we do this? Set this thingy equal to, solve it for y and then substitute it here. Right, let's do that. So here, fy is equal to 0. So from there, we get y is equal to negative x squared over 2. Good. Now substitute it to this thingy. So we have 2x plus 2xy is equal to 0. And we are going to take that y and substitute it right here. Okay, so we have 2x plus 2x times negative x squared over 2. And this OneNote is behaving weirdly. So far so good. So we get dividing, well, no, not dividing, 2x minus, we have x cubed is equal to 0. So from here we get x here, and then 2 minus x squared is equal to 0. Eh? So far with me? Too much algebra? You got this, right? Okay. So either x is equal to 0 or x is equal to plus or minus square root 2. And the y value that goes with it is, we get it from here. So if it's 0, this is 0. And if it's x squared over 2, we square it. And then so we have negative 1, eh? So far so good? Now there's a problem with the second one. Do you see what the problem with the second one is? What is wrong with this? This is a nice solution.
It's out of the boundary.
It's outside of this boundary. So on a zoomed out picture, we saw something lower, right? But here, it's outside of our boundary. So we throw this away. So the only thing, only candidate is that point right there, 0, 0. You know what I'm saying? So we get 0, 0 out of this. Okay, now we're going to compare this value. So this is one of the candidate. And since we are pretending we cannot see this picture, we don't know whether that's a max or min or saddle point. We don't know. Only thing we know is it's flat. So it's a critical point. Okay, let's look at the boundary then. Okay, the boundary is a little tricky, but let's do it like this. I want to look at where along this line right here, this boundary. Okay, the one way of denoting that is x comma 1. You know what I'm saying? Y is equal to 1. Okay, let's go back to our graphics. So this is x-axis and that's y-axis. Y is equal to 1 means this thingy. Right there, that boundary. Do you expect this thing to look like a parabola, right? Let's see if we really get parabola out of it. Okay, so from our function, y is equal to 1. So this becomes 1 and this becomes 1. So do you see that this is 2x squared plus 5? Too much algebra? No? And of course, that's a parabola indeed now, isn't it? So that function will look like this. Right, and it's very symmetrical. And this point is 1, 1. And this point is negative 1, 1. And this point is 0. Okay, this is a little misleading. Okay, let me put this thing. Is it better? Because it's not a y value, I mean z value that I'm putting in, it's just candidate, the point. Okay? It's, you guys look puzzled, it's just this thing. We don't know what that value of the function, what z value is, it's just, I'm just putting down the coordinate above this thing. Am I making sense to you? This, along this line is going to be a parabola, is all I'm saying. Good? So from here, I get 3 candidates. This one, and of course this one. You know what I'm saying? And in 3D graphics, see, this is, turns out to be maximum, these two, pi, and that is a candidate, and it will not be our absolute min because it's higher than that point, but we have no way of knowing that. Okay? Okay then. So there's one candidate, and then let's look at another candidate. I'm going to look at this one along this thingy, this line. Okay, so when x is equal to 0, so f of 1 comma y. Okay, let's look at it. So we plug in 1 for this and this, except I notice this is there both squared. So even if I put -1, it'll be identical, right? So I'm going to put plus or minus 1 comma y. How's that? And that will be y squared plus y plus 5a. Say yes. Let's look at it again. If I put, this becomes 1, so add it to 5, and this becomes 1, and this, I mean, there's nothing, and there's 1. You get it? You with me? Okay, this one is not as obvious, so we'll have to take a derivative. Although we can kind of say it's that -1/2 is from your algebra. Let's take a derivative. That does not look good, so plus or minus 1. So if I take derivative with respect to y, plus or minus 1 comma y, this thing becomes, of course, 2y plus 1, right? And if I set that to 0, that tells you that y is equal to -1/2. You know what I'm saying? So what we have here is this kind of parabola. This kind of parabola. So this point right here is your x happens to be plus or minus 1 and y happens to be -1/2. This is f of that thingy. And this point happens to be f of plus or minus 1 and positive 1. And this point happens to be f of plus or minus 1 and -1. Okay, let's go back to this thingy. It's a side view here, this thingy. You get it? That kind of looks like a parabola, doesn't it? So x is equal to 1, y is equal to 1 here, and x is equal to 1, y is equal to -1 here. And then, of course, it looks identical on the other side as well. Good? Okay, so this is definitely not much, right? Because that one, we kind of know, but we'll compare these values anyway. So we get 1, 2, 3 candidates. Okay, and lastly, I'm going to put when x is equal to, when y is equal to -1. Okay? I'm gonna put them down here. So f of -1y. Wait. When y is equal to -1, down here. So we consider this first and these two, and then now lastly here. So when f of x and y is -1. Okay, let's see what that gives us. So if we put -1 for this, -1 for this, what we get is this thingy cancels that thingy, right? You see, -1, this x squared gets cancelled by that x squared. This becomes 1, so the whole thing is constant. This is 5. Right? Good. Wait, was it constant? Let's see. Yes, you see how flat that line is? So it is constant along that line when y is equal to -1. Good. Okay, that is our candidate, nevertheless. Okay, now since we are looking for the absolute, okay, we have to consider all of these. Okay, I have one here already, so I'm gonna have to put, let's see which one. Oh, let's put 0, 0. And what was the value at 0, 0? If I plug in 0, 0 here, then of course I get 4. So this is 4. So that that one just lost because this will be our leading contender for the minimum at the moment. You know what I'm saying? Okay, and then f of, which one was it? Oh, okay. 1, 1. And -1, 1. Okay, let's put that one. So plus or minus 1 and 1. Okay, if I put those two, so this becomes 1, this becomes 1, everything becomes 1. Even if x is negative, that gives you the same thing. So we have 1, 2, 3, we have 7. So far, so good. Okay, that of course is right here and right here. That thingy includes this point too, right? This point and this point are the same thing. Are you confused or are you getting this? Your facial expression does not look good. Are you with me? Okay, now, then I'm gonna put f of, now the other point, well, I'm gonna calculate this now, right? So f of 0, 1. If I put f of 0, 1, x is equal to 0, y becomes 1, so that's 5, right? Well, that doesn't make it because already we have 4 and 7, right? These two are the leading contenders at the moment. And then I'm gonna have to put f of x is plus or minus this end right here, right? And not that end, this end right here, okay? And y is equal to -1, okay? So if I put y is equal to -1 and x is equal to 1, this becomes -1, which cancels this, right? And we still have 5, right? Okay, doesn't look that good. And one left. Last one is this one right here. So f of plus or minus 1 and -1/2. Right? That's a lot of calculus. For some reason, kids at this level struggle with fraction, multiplication, and addition. So if I just cheat, well, I mean, do it in my head, it'll turn out to be this, which is still slightly higher than that one, right? If we go back to the graphics, this side one right here, this point, it's still slightly higher than that one right there. You get it? So comparing all of that, now we can see this one is our minimum, and this one is our max. And then everything else is just neither, because we are looking for absolute max and absolute min.